Hello, in this video, you will be introduced to the data science library trio, Numpy, Pandas, and Matplotlib. These libraries power almost all data science tasks, as they are the backbone of many libraries we use in data science. This is actually a very big topic, and there are so many things you could do with those libraries, but for this video, we will just cover some of the essentials, the things that you will be needing most of the times when you do your data science analysis. And as usual, since this is a third-party library, we will have to import them. So you will typically see these three lines: import numpy as np, import pandas as pd, import matplotlib.pyplot as plt. Okay, so now let's start with numpy. So numpy stands for numerical Python. It is an open source library in Python for performing scientific computations. It lets us work with arrays, matrices, in a more natural way, unlike lists, wherein we have to loop through individual elements to perform a numerical operation. And as a refresher, here are the basic descriptions of array and matrices. Arrays are simply a collection of values of same type indexed by integers. Think of list. And matrices are defined to be multi-dimensional array indexed by rows, columns, and dimensions. Think of nested lists. We highly recommend using NumPy library because it is designed with high performance in mind. It is largely written in C, which makes computations much faster than the typical Python code. And it is stored more efficiently than an equivalent data structure in Python, such as lists and arrays. Again, this is a third-party module, which means it is not part of the typical set of libraries that you have in Python, the built-in ones. Here are some important notes on NumPy arrays. All elements in a NumPy array must be of the same type. The size cannot be changed once constructed. And it supports vectorized operations such as element-wise addition and multiplication. So let's get started. How do we initialize an array? We simply plug in an iterable inside np.array. So iterables are like lists, tuples, they are iterables. So you have a list here, 1, 2, 3, 4, and you plug it inside the np.array function. Now you end up with a numpy array. You could also create a numpy array through np.arange. If only a single argument is passed, let's call this n1, it creates an array of size n1, starting from 0 to n1 minus 1. If two arguments n1 and n2 are passed, it creates an array starting from n1 to n2 minus 1. For example, we plug in 5. So since it is 0 index in Python, you'll start at 0 and then you go up until you have 5 elements. So 0, 1, 2, 3, 4. You do not include 5. So you have 5 elements here. Now you have a numpy array containing 5 values. Those are 0, 1, 2, 3, 4, and the data type is float. There's also another example here. You specify the start. So you start at 2, and then you end before it gets to 5. So array containing 2, 3, 4. There's also some built-in attributes that you can use in NumPy. This is very helpful. Here are some of them. So there's ndarray.ndim, ndarray.shape, ndarray.dtype, ndarray.itemSize. The ndim is the number of axes or dimensions of the array. .shape is the dimension of the array. .dtype is the type of the elements in the array, and item size is the size in bytes of each element of the array. So we just print it so you can see. Now, how do we access and manipulate the elements in our array? Similar to the syntax of Python list, you could also perform indexing and slicing. So how do you do that? Let's start with this array here. So you do indexing, so it's bracket 6, then closing bracket, and then you get 9. Why is that? Because 9 is the 6th element in our initial array. 0, 1, 2, 3, 4, 5, 6. Sorry, it's the 7th because it's 0 index, so 6 is 7th element. Then you could also perform slicing, so it's colon 4. That means you start the very beginning up until you get to the 4th element. So it's going to be 3, 4, 5, 6. Now you have 4 elements, you stop. You can also indicate the number of steps by adding another colon and an integer number after the slice syntax. So colon 4, now you add colon 2. That indicates the number of steps. Now you skip 4 and 6 here because it's 2. Basically by default this is 1. If you do colon 1, then that's nothing. You can also perform arithmetic operations on Numpy matrices like in linear algebra. Be careful with the dimensions though. Make sure that there is no mismatch for a particular operation that you will be using. In this example, we have created two matrices having a shape of 3 by 3, so 3 rows and 3 columns. And here we just perform an addition using the plus symbol. It's element-wise addition. It also performs subtraction using the minus symbol. To perform element-wise multiplication, you use asterisk. To perform element-wise division, you use slash. To do a proper matrix multiplication, we use np.dot method or function. So now this is matrix multiplication. You can also get the transpose of a matrix. So you start with this array, now you just use the .t attribute, and it is now transposed. You can also get the inverse of a matrix by using the np.linalg.inverse function. Now this is the inverse matrix, I mean. You also have logical operators, and those are or and not. So this is the syntax for that. There's np.logical or, np.logical and np.logical not. So it is going to be true for the first example because true or true is true. As long as there is one true, then it's going to be true. False true is going to be true. False false, there's no true, so it's false. For and, both have to be true. So the first element here is true because it's both true. But for the other examples, there's one false, at least one false, so you get a false. And finally, the not, well, you just basically invert it. So true becomes false and false becomes true. We also have different aggregation methods in Numpy. So there's sum, max, min, standard deviation. We start with this matrix here. We could get the sum by using the .sum method, and it returns the sum of all the elements here. But what if we want to specify the dimension? So in this example, we specify axis equals 0. It basically squishes our matrix vertically. So all the elements here, all the elements in column 1 will get squished. You get the sum of that. And then all the elements in column 2 I mean, will get squished. You get the sum of that. And for the column 3, same stuff. So you get the sum of that. Now we end up with an array of 3 elements. If you want to do it horizontally instead, use axis equals 1. The same goes for the other aggregation methods. There's max, and if you want to specify the dimension, you could do that as well. Axis equals 0 and axis equals 1. Same goes for a minimum and standard deviation. There's also mean, you can also do that. And that's it for the Numpy section.